way back at the beginning of the semester, I gave you a derivatives and integrals sheet. So this is your differentiation formulas, and on the back side, you've got integration formulas. I'm going to re-upload this into Canvas. I have not yet, but I will. So if you don't have it, if you've lost it, you can print it off for at home. But we are going to now start undoing everything that we've been doing. So we've got integration is going to be the inverse of differentiation. Okay, so we are going to undo. So when we think of inverse, the inverse of addition is subtraction because it undoes itself. The inverse of multiplication is division because they undo each other. The inverse of something squared is square rooting because they undo each other. Okay, so what we're going to do is work backwards, and I'm going to kind of sort of talk you through, but the first thing I want to do before I do all that mess is talk to you about the symbols that we use and the verbiage that we use. So first of all, what you're going to see is this cool little symbol, and that's called the integral. So that's vocab word number 1. We have the integral, and if there are little numbers on top and bottom, we call it a definite integral. So definite, in other words, defined. If there's not little numbers on the top and the bottom, we call it indefinite. So indefinite. The function that we're going to put after the integral is going to be called the integrand. So I'm just going to make something up. So I've got a 2x squared, okay? And then dx. dx means I've taken the derivative of something. So this is the derivative of something. The process of integration is going to be undoing that. So what we learned with differentiation is that the basic general definition of a derivative, your first derivative will tell you instantaneous rate of change or velocity. Your second derivative will tell you acceleration. Okay, if we're undoing this, it doesn't go backwards necessarily and mean that. Your basic definition when you integrate, the result of integration will give you a formula for area under the curve. Okay, it is a formula for area under the curve. So this as it stands, if I were to graph 2x squared, okay, all that is a parabola that's pretty dang tall. Okay. When I integrate this, I'll get the formula for area under the curve. And so it would be like this type of area. It will become a definite integral when I give you the x values that I want you to find the area between. So if I wanted you to do the area between 1 and 4, okay, I would just want that part of the area. But we're going to get to that later. All right, so we're going to talk you through a couple things. First of all, go back to differentiation. So if I want to take a derivative, and I'm going to ignore this one, I'll come back to that in a second. If I want to take a derivative of, say, 4x squared plus 3, okay, what is the derivative of 4x squared? So we drop our 2 out front, drop your exponent by 1, and then the derivative of 3 is 0, correct? So then I would say, well, I took the derivative of x, so I'm going to put a dx. So just like you introduced dx when you took a derivative, the dx will go away when you integrate. Okay, this is just part of the symbolism that we have. Now, let's do it again. What if I have a 4x squared plus 17? What's the derivative? The derivative is going to be 8x dx. Okay, so what do you notice? When I took a derivative, I had a constant, and the derivative of a constant is 0. So when we integrate, we're going to put a plus capital C at the end when we integrate, because what we're doing is we're saying there could be a constant that was there. Okay, so that's basically what we're saying. Now, a few of these things, so here's what you're going to notice. If I have the integral of a is just a number. Okay, the integral of a is going to be ax plus c. Well, where did the x come from? So let's talk about that for a second. If I have the integral of a, oops, sorry, I just lied. The integral of a dx, where a is a number. Okay, so it could be 7. I don't care. Well, remember, I can have an x to the 0 sitting there. So here's the process of integration that we're going to use. We're going to increase our exponent by 1 and then divide by our new exponent. So the integral of x will become x to the first over 1. So this constant is going to come along for the ride, and then this will become an x to the first over 1, which I'm too lazy to write. And then I put a plus capital C, or a plus big C, to say, well, there could have been a constant there when I differentiated, and we'll resolve that later. But for right now, that's what we're going to do. All right, another thing that you need to know is this says if I have a function plus or minus another function, that I can separate it out and I can do it term by term. So just like when I took derivatives term by term, I can integrate term by term. And then this is essentially what I just told you that we're going to... Text message. I'm so sorry. This is what I told you that we're going to do. And that is going to be... hang on. I'm silencing my cell phone during class. All right. So what we're going to do is we're going to take that exponent and we're going to increase it by 1 and then divide by our new exponent as long as your exponent is not -1, and we'll get to that later, okay? And then same thing. I may have a u to the a, so I increase my exponent, but this is going to be, we're going to have to balance later on. It gets a whole lot more complicated. But, and then we've got e's and we've got exponentials, and this also says if I've got a constant multiple, I can bring it out front and pull it along for the ride, okay? And then this one is going to be natural logs. Integration by parts we'll get to later, and then we've got a couple of other things. So again, this is your kind of sort of little cheat sheet, but I'm going to do a few of these, and then we'll just go from there. So, and again, I'm going to beat this to a bloody pulp, but this says the integral. Oh, hang on. I was going to tell you about this one. Go back. All right. So if I wanted to integrate this, the integral 2 can come along for the ride. I increase my exponent by 1. So this answer would have been 2x to the third and then over 3 plus big C. That is the formula for this area between whatever values I give you, which we'll do later. So that is our basics. Now, going through here, and I'm fighting a cold, so no fever, it's not coronavirus. Anyway, I've got the integral of 22x dx. So what is my process? I've got a single term here. What you could do, and what you're going to want to do later on, is going to be pull this 22 out front. So he's just coming along for the ride, because we only integrate wherever we've got variables, okay? So what I'm going to do is increase my exponent by 1 and divide by my new exponent. So this 22 is coming along for the ride. And then this will become x squared, because there's a 1 here, over 2. Plus big C, and then I clean it up. Well, I know what 22 over 2 is. It's 11. So that becomes 11x squared plus C. And so that's your answer. That's what you're going to do. So we're just practicing this as we go along. So this one says I have an 8 dx. Well, I can pull that 8 in front. And remember that there's an x to the 0 sitting here that I'm too lazy to write. So when I integrate, this 8 comes along for the ride. And then I have x to the first over 1 plus c. Okay? Hang on. All right, so moving on. We have the integral. Now notice we've got parentheses around this one. So it says the integral of 16x plus 7 dx. The reason that we're putting that in parentheses is because I've got multiple terms. The integral belongs to all the terms, and the dx belongs to all the terms. So really what this says is 16 times the integral of x dx plus 7 times the integral of dx. But I'm too lazy to write all that stuff out. So since they both have an integral and since they both have a dx, I just take it and I put it out front. And by the way, this symbol, it does look like a long skinny S, and that's actually important for later on. But it is. It's a long skinny S, and it's an operator, just like addition is an operator. So if I put plus, you would know to add something, correct? When I see this symbol, it's an operator. It tells me to integrate. So after I integrate, it disappears because I did what it told me to do. Okay, so that's an operator. All right, so when I integrate this, I'm not going to mess with all this kind of stuff. I'm just going to remember I can go term by term. So 16x becomes 16x squared over 2. So 16x squared over 2 is going to reduce to 8x squared. Okay, and then what's the integral of 7x to the 0? It becomes 7x. And then do not forget your plus big C. Okay, and then just go term by term. So I'm just going to go a little bit faster. I have a 9x squared, so that's going to become a 9x to the third over 3. And then I have a minus 6x. That's going to become a negative 6x squared over 2. And then I have a plus 3, which is going to become a plus 3x, and then plus c. Okay? All right, so let's do it again. We have 2x to the third is going to become 2x to the fourth over 4, which is going to be x to the fourth over 2, because 2 over 4 reduces to a half. Okay, plus 4x to the third over 3, minus 5x squared over 2, plus 2x, plus c. And then I have find 9 times the square root of y. Well, just like we had to do with differentiation, I'm going to have to rewrite that thing. So I'm going to rewrite it as 9 times the integral of y to the 1/2 dy. Notice that your variables match. Okay, so that dy is telling you what variable you're working with. So that's going to become y to the 3/2. So I've got 9 y to the 3/2 over 3/2. Well, what happens when I divide by a fraction? It changes into multiply by the reciprocal. So flip it. So that's actually going to be times 2/3. So I get 18/3, which is 6. Okay, so 6y to the 3/2 plus c. And now this one, I've got the integral, of 8x to the 1/2 plus the square root of 11 dx. Now don't let that freak you out. Do you see a variable? No, that's just a number. So he's coming along for the ride. So this becomes 8x to the 3/2 over 3/2 means times 2/3. So I get 16/3 x to the 3/2. And then the square root of 11 is just a number. So what's the integral of a number? It's the number then times whatever variable you're working with. So I'll get plus the square root of 11 times x. Don't put that x underneath the radical. Plus big C. Okay, so I'm going to pick the rest of them up on the second part of this video.